Hello and welcome to the AHAMA Highlight webcast. In the run-up to AHAMA, with only a couple of days to go, we want to give you another glimpse on the trends that shape and change the process industries. Before next week, you will have the chance to experience everything hands-on and live here in Frankfurt, learn more about all the technological solutions that are already available or in the pipeline, discuss with providers, with users, and with engineers and chemists and biotechnologists and everybody active in the process industries, what is to come and what is to be. And live and hands-on is the keyword for today as well. You can join us here in our webcast with your questions and comments live. Just use Slido. This is sli.do and the hashtag AHAMA Highlight. Ask your questions, post your comments, and we will pick them up here in our discussion. Now, one of the biggest issues, as we are all aware of, is hydrogen. The hydrogen transformation, the transformation of the chemical industry and many other industries as well. And we have been discussing this topic already in some of our webcasts, covering questions of generation of hydrogen and the use of hydrogen. But in between, there is the issue of transport and storage, of course. Now, hydrogen is a very small molecule, so there are issues of loss prevention, there are issues of safety as well, of course. And one of the pilot projects funded by the German Federal Ministry for Research is targeting exactly this step in the value chain. It's the TransHyDE project, and it's my pleasure today to speak with Professor Mario Ragwitz. He's the head of the Fraunhofer Institute IEG, which stands for Energy Infrastructures and Geothermal Energy, and he's one of the coordinators of the TransHyDE project. Welcome, Professor Ragwitz. It's a pleasure to have you here with us.
Thank you. It's a pleasure to be here.
Professor Ragwitz, there's the big question. We can generate hydrogen. We have learned about that. We know how to use it. But in between, we have to move it somehow and we have to store it. How is the TransHyDE project tackling these questions?
The TransHyDE project is one of the 3 flagship projects of the German Ministry for Science and Research, is tackling this question in a very holistic way. The other 2 flagship projects are actually on hydrogen generation, which is covered holistically, and on maritime use of hydrogen. And we in TransHyDE consider all solutions for transport and storage. So this includes in particular gaseous and liquid hydrogen storage in any form or transport. So via pipelines and via containers in ships, railway and truck transport. So in particular, we are looking at the needs for new built and transformed pipelines from natural gas transport, for natural gas transport, as well as synthetic derivatives of hydrogen, like, for example, ammonia or liquid organic hydrogen carriers, LOHC, which are applied in different case studies at industrial level, really large-scale pilot projects. And TransHyDE combines 5 research projects where these technologies for hydrogen transport and storage are developed further, and 4 application-oriented projects where industrial scale-up production and transport of hydrogen is actually implemented. And in these research projects, we look, as I already said, at pipeline transport and needs for new materials for pipelines, including also sensor technology. We look at liquid hydrogen transport, also in combination with superconducting electricity, so combining hydrogen and electricity transport. We look at new forms of ammonia synthesis and transport. And we also look at all types of standardization norms and certification of new hydrogen technologies in order to bring those into the markets. And then once these technologies are developed, they will be applied in the application case studies and projects. And this is, of course, very interactively interlinked. So all the barriers we discover in this application projects are then fed back into the research projects so that each of those technology streams can be developed further.
So a very, very broad scope and a giant project, I suppose. We know that hydrogen can be used in very different applications, the process industry, the steel mills, mobility. How adaptable are the solutions for transport and storage, or do you have to develop them for each industry separately?
Actually, transport and storage technology are the basis for any type of large-scale use of hydrogen. So wherever we have a major and larger scale demand for hydrogen and hydrogen derivatives, transport and distribution infrastructures and storage will be needed, and therefore we are a little bit agnostic to the different industrial applications. And so maybe one should differentiate between decentralized use and centralized use of hydrogen. Since the no regret options that we have seen in German hydrogen strategy and in a wealth of various studies, including the major studies of the German Hydrogen Council, we see that the first no regret options and use for hydrogen are in the energy intense industry, chemical industry, steel industry, refineries, as well as in large scale transport applications, like, for example, aviation and also large or heavy duty truck transport. And for all of those applications, we need large demands of large volumes of hydrogen demand. And for these, we will need large scale infrastructures. And those include in particular the pipeline systems and the large-scale container-based solutions, like, for example, for ammonia in the phase of the scale-up of a hydrogen market. And this will have to be connected to harbor infrastructures because, as we know from, again, from the different studies and from our elaboration in the German Hydrogen Council, that about 2/3 of the hydrogen demand will be imported. So all the infrastructure and storage options need to be connected to the import hubs, and here in particular harbor infrastructures, but also pipeline connections to other European member states are of critical importance.
Now, you already mentioned that using existing infrastructure might also be an option, but there has to be built some more probably. Last week, even riding on a train, I think it's a topic that has reached the general public because people were discussing on the train how much hydrogen you can actually put into a natural gas pipeline for communal use. Do you have any estimate, or could you tell us a little bit more about how could existing infrastructure be used, or are there limits? Because hydrogen, well, of course, is not natural gas, and a carrier molecule is not petrol. So where are the limits there? Are the opportunities, of course?
Absolutely. This is actually also one key aspect that we are researching in the TransHyDE project with a number of partners. First of all, we have a limit based on the existing natural gas infrastructure, which will be needed in the transition period also for natural gas transport. And until the war in the Ukraine and the changes in the gas supply from Eastern countries, particularly from Russia, we thought that we might have in the transition period rather quickly transport infrastructures, gas infrastructure available for transporting gas from the northwestern European import hubs, like, for example, Rotterdam, to Germany, for example, and other Eastern and Central European countries. Probably this will be more difficult now because a large part of these infrastructures will be needed in the transition period for natural gas infrastructures. There are different studies, among them in particular the European Hydrogen Backbone Study, also the studies of the gas transport system operators that have assessed the need for new build hydrogen infrastructures. And these studies came to the result that 20 to 30% of the hydrogen infrastructures, hydrogen grids, will be based on new build, and the other 70 to 80% would be refurbished or repurposed natural gas pipeline. For as explained, the situation has slightly changed, and so we think, and our modeling shows that the share of the new built hydrogen infrastructure will be actually larger than we have seen in the first assessments that have been performed. And then the question arises, and this you have touched upon that as well, what needs to be done in terms of material requirements and adaptation of the gas infrastructure. And actually, this is something we're looking at in detail in the TransHyDE project, where we assess the quality of different materials of steel, also of the different pipeline elements, sensors and compressors, etc., to which extent they are ready for hydrogen transport already today. And we see that large share of the steel will be, or the steel types used for natural gas pipelines will be suitable also for hydrogen transport, but it depends on each different pipeline and has to be assessed in detail. And we will also have to change the compressors, and will need new sensor technologies, but these are all manageable adaptations to the existing natural gas grid. And therefore, to cut a long story short, yes, we look in detail also at the reuse of existing infrastructures, and this will be in particular possible for the gas grid, but also for some other hydrogen carriers, like for example for LOHC, we can easily use existing oil infrastructures, where LOHC can be transported very similarly to traditional oil.
Sounds quite reassuring, at least that we don't have to build everything newly from scratch, because 70 to 80% of reuse, even if it has to be adapted, is a lot, I think. We have the first questions coming in, and one of them also deals with the infrastructures. I'm just going to pass it on. Do you also develop ideas on how to govern infrastructures, particularly on the international scale?
This is a very interesting question, and yes, we are looking at that at the next step. Actually, in the overall system analysis, we first look at the need for transport infrastructure, also international transport infrastructures within Europe and even beyond Europe, for example, connecting the MENA region and Europe. And this is the first important step. We need to have a robust estimate of the demand for international hydrogen infrastructures, in particular grids. And there's an intense discussion, and not all member states of the European Union share the same opinion so far. And but there's some convergence, and so we put a very important scientific basis with our modeling here. Secondly, and this is concerns the question, is the question of regulation and governance of international hydrogen infrastructures. The first step here is for the initial grids and demonstration projects in the important projects of common European interest, IPCEI, where we also look at the IPCEI project implementation and how scale up is possible here. And the third issue is whether hydrogen infrastructures can actually be governed by regulations similar to the current regulation for natural gas, or whether, at least in the transition period, new elements are important. Maybe a mixture of investment grants by governments and regulated assets infrastructure regulation. And we are developing ideas for that and regulatory approaches, and discuss that also with regulators, with ministries, but also with TSOs for hydrogen infrastructure. And yes, that's a topic we're looking at quite into in some detail. As I said, based on the modeling exercises, we are looking into all these legal aspects. This concerns also the certification for green hydrogen based on the Renewable Energy Directive 2 and the delegated act from there, and then all the the gas package or the gas package provided or suggested by the European Commission and the implementation at member state level. And actually, we look at that in quite some detail. And I mean, there is, for the overall hydrogen market, there is this triple-handed act problem, as you call it. So we need to create demand, supply, and the infrastructure. And similarly, policymakers also look at instruments to support supply of hydrogen and the demand of hydrogen and the infrastructure. And all of that has to be brought together and thought holistically. And therefore, any type of investment incentive, for example, together with regulated approaches for hydrogen infrastructures, need to be thought in connection to the demand elements for hydrogen, like, for example, contracts for difference, carbon contracts for difference. And that's a topic we're looking at in quite some detail. And we have also, besides our the engineers and economists working in the project also legal expertise within the project, and so we need to look at that really from an engineering, economic, and legal perspective, and that's what we're pursuing at the moment.
Yeah, it's a true transformation. I think it's not just a technological issue, but it takes much more. We have another question. So if you have another question from the audience, you still have the chance to post it via Slido, as one of you did. And this also concerns infrastructure. I mean, we all know this about electricity, but how can the south of Germany receive hydrogen in due course if all the imports arrive in the north? It's very similar to the electricity question that we are facing and haven't really solved, I think, over the last couple of years.
You mean how can hydrogen infrastructures adapt all the if all the imports arrive in the north? Yeah. I mean, therefore, I said we need the holistic picture, and there will be, of course, in the first step, major imports arriving in the north. But in the next phase, we also see opportunities for imports from the south, in particular from the MENA region, from starting first from Portugal and Spain, and maybe also Greece and maybe Italy. But then in the next step, also from North African countries, Algeria and Morocco in particular, and Tunisia, where we then could have pipeline-based imports also from the south. But I'm fully right, at least in the first period, there will be the harbors in the north will be important backbones. We have strong infrastructure also from the north to the south in Germany. Currently, large parts of our natural gas imports come from Russia and Norway, all integrated into the German natural gas system from the north. And so we will probably need additional import terminals and then also pipelines, in particular from the harbors, let's say Rotterdam and the German North Sea harbors and the Baltic Sea harbors. But the natural gas infrastructure, which can be adapted, is already quite strong in that respect. And maybe one aspect about that we see for the first phase of the hydrogen imports, a very little share of pure hydrogen imports in form of liquid or gaseous hydrogen via harbors, but via derivatives, in particular ammonia, for example. And these ammonia imports will also be used in the first step directly for replacing domestically produced ammonia. And therefore, the question rather is, for example, how to handle ammonia in existing harbor infrastructures and how to transport then ammonia from the harbors to the centers of use. We will not transport in the first step hydrogen directly, but only in the second step via pipelines then from different neighboring countries.
Mm-hmm. How big is the role of preventing energy losses? I mean, a lot is about logistics, using pipelines, using containers, but also every conversion brings an energy loss. So how do you handle this? And is there an ideal solution, so to say?
Yes, also very important and good question. Since energy loss is certainly something that needs to be considered in an efficient transformation of the system. We will need to concentrate in the mid and long term on the most efficient means to transport and store hydrogen. And therefore, I really would like to stress that gaseous hydrogen will be the key element in the medium term. So we will think of a large-scale European hydrogen backbone, hydrogen pipeline system, because for every transport distance below 1,500, 2,000 kilometers, gas-based hydrogen transport is the most efficient solution. And therefore, we will try to, of course, we will have to try to avoid as many unnecessary transformation steps. And therefore, in the first step, we'll see, for example, ammonia imports where ammonia use can be replaced. And there we also avoid unnecessary transformation steps because we import ammonia, which will just need one transformation step from hydrogen to ammonia, which will have to be performed anyhow. And then it's an open question whether ammonia cracking will be competitive with gas-based hydrogen imports, for example. And this is something that also the market will have to decide. And from the system analysis, we definitely assess the most efficient hydrogen import pathways. And here, efficiency is a very important element, and therefore avoid unnecessary transformation steps. That's definitely an issue.
Okay. Well, I think we all got an impression on how complex the whole topic is and how much there needs to be discussed. A lot of food for thought, a lot of food for discussions at ACHEMA next week, and we will see you there. So I'm really looking forward to it. Thank you for being with us today.
Yes, thank you. And I also look forward for ACHEMA and for discussing maybe with some of you in the audience further results and implications of the TransHyDE project.
Thank you. See you there.
Yeah.
And for all of you who are planning your visit to ACHEMA right now, if you are interested in hydrogen, Monday and Tuesdays are the days to be there. We have the Hydrogen Monday, so to say, with sessions on the handling on the transport of hydrogen, on materials for hydrogen. Some of the mentioned projects of the BMBF will present their results and their project structure. We have the highlight session, of course, on Monday on hydrogen use in the industry. The TransHyDE project will have a session on Tuesday at 2:30. And over the whole week, you can visit all the hydrogen projects that we have presented here in Hall 6 at booth A36. This is the Research and Innovation Hall, and the booth is easy to find because it's really large. Apart from hydrogen, what do we have to offer? Well, of course, everything that's needed in the process industries, from the lab to the packaging line. So whatever you're looking for, whatever you want to learn, whatever you want to discuss, come to ACHEMA. You will find it there. You will find the right people to speak to. So get your ticket now on the website, download the app, prepare your visit, and I hope to see you next week at ACHEMA.